Okay, so today's lesson is on factoring trinomials, and we're going to use a method called split the middle. Before we do that, we're going to kind of look at how this works in reverse. So use distribute property to multiply the following binomials. So we're going to distribute this. We get 5x squared, and if we go here, minus 10x, and then minus 3x, and then plus 6. And you think about this is what we were doing yesterday with the grouping. Now we've got this expansion. We can then group and we can factor and get back where we started, or we can just combine this and get 5x squared minus 13x plus 6. Right? And that would be the simplified version of this if we wanted to simplify instead of expanding. So we're going to look at this problem and how we can work and get back to these factors, starting off with this. So the steps for split the middle, which is our most common used way to do factoring. You can also do tabular and different methods to try to figure out the factors. But the steps for split the middle is first you always check for a GCF. Every problem you're going to check to see if there's a greatest common factor first. And if not, we're going to expand our binomial by splitting the middle. So we're going to split this 13 into negative 10 and negative 3. But we're going to have a process to figure out which factors to use, because 13 could be 6 and 7. You can make 1 and 12. There's a lot of different factors, 11 and 2, that would make 13. So how do we know to use 10 and 3? And then the last thing we're going to do is factor by grouping, which is what we do to get back to this step. So we're going to work this in reverse. So let's look at this example and work this. So step 1, apply the pattern, and we're going to look at this middle term and know that we need to get two terms. So find the way to do this. We're going to take the first number times the last number. So A times C, which is 5 times 6 is 30. And we need to add to the middle number, which is B. So the sum needs to be negative 13. So we're going to try different numbers. What multiplies to 30? So we could say, well, 5 and 6 we know do. So 5 times 6 would give us 30, right? And if we add those, we get 11. We could also do negative 5 times negative 6 and get 30, and that would give me negative 11. Remember, we're trying to multiply to 30 and add to negative 13. So what else multiplies to 30? So you might say, oh, 2 times 15. That would give me 17. What about negative 2 times negative 15? Negative 17. What about 3? 3 times 10 is 30. That would give me positive 13. But negative 3 times negative 10 gives me negative 13. So there's my factors. So once again, you're trying to find two numbers that multiply to 30 and add to negative 13. Right? Typically, I call this the X method. I typically run this like this. The A times C goes here, and the B goes here. So A times C is 30, and we want to multiply to get to that, and B is negative 13, and we want to add to get to that. And what I say is then find the magic numbers. I call the magic numbers the numbers that make this work. So in this case, negative 3 and negative 10 are our magic numbers. Negative 3 times negative 10 is 30. Negative 3 plus negative 10 is negative 13. So we're going to kind of use this X method to keep it organized. So now we're going to replace M and P with those numbers. So we're going to go back up to our equation. We had 5x squared plus mx, which we're going to put as negative 3x, and then plus px, which is negative 10x, because m and p, basically, you can put either one, either order, it doesn't matter, and then plus 6. So we're replacing or splitting the middle. We're splitting the 13 to 3 and 10, which make 13. So we haven't changed the value, but by splitting it, we can now use grouping, which we learned about yesterday. So what is the greatest common factor here? It's x, so it would be x times 5x plus x times negative 3. And then we take the x out, we get 5x minus 3. And then over here, the greatest common factor, if this is negative, I always like to factor out the negative, would be negative 2 times 5x, and negative 2 times 3, times negative 3 in order to get the positive 6. So we factor out the negative 2, and we get 5x minus 3. And then we should be very happy and smile. As I always say, you're supposed to smile. If these are the same, that means you're on the right track. So that is now your greatest common factor. We factor that out. and we're left with x minus 2, and now you have factored your trinomial. And as you can see, that is the answer that we started off with at the top. Okay, so now we're just going to look at a bunch more examples of doing this together, and then you'll have a practice worksheet. So again, I always use this x because I feel like it's easiest to follow. So the x is here, multiplication on the top, addition on the bottom. First number times last number goes on the top, so that's -2. And the middle, which there's an invisible 1 there, goes on the bottom. So we're looking for the magic numbers, what multiplies to -2 and adds to 1. And so 2 times -1. 2 times -1 is -2. 2 plus -1 is 1. So now we're going to take that middle and we're going to split it. And we're going to replace it with 2x, which is from here, and then minus 1x. And 2x minus 1x is 1x, so that hasn't changed. And then we bring down the first term, 2x squared, and bring down the last term, -1. And now we're in a group. And the GCF here is 2x, so 2x times x plus 2x times 1. And then take out the 2x, and we get x plus 1. And then over here, the greatest common factor is -1. So we have -1 times x and -1 times 1. If we pull out the -1, we get x plus 1. And now we smile because these are the same. So now x plus 1 becomes my GCF. When I cancel that away, I get 2x minus 1. And I factored. And you should really distribute and check these. Obviously, since I'm doing it, you know you got it good. Hopefully, I didn't make any silly mistakes. But when you do them on your own, you should really distribute and check to make sure they work. It's like a way to check in and know you have the right answer. So this one here, before we do anything else, step 1 is always to do a GCF. This factor has a GCF of 3. 3 goes into all of these. So I'm going to factor the 3 out first and get x squared plus 5x plus 6. And then this is what I'm going to put into my split the middle. So there's a 1 in front, a 6 at the end. So 1 times 6 is 6. And 5 goes on the bottom. So we need two numbers that multiply to 6 and add to 5. And that would be 3 and 2. So we're going to split the middle to 3x plus 2x. Bring down the end and bring down the beginning. Okay. And this 3 here is in front of the whole thing every time. Okay, that's still a factor. So now we're in a group. And I'm going to do x as my GCF. So x times x plus 3 times x. We're going to x times x plus 3. And over here, 2 is my GCF. 2 times x and 2 times 3. So I get 2 times x plus 3. And again, this 3 is in front of the whole thing. So now I smile because these match, and I have 3, and I'm going to take my x plus 3 as my first factor, cancel those out, and get x plus 2 as my second. And that is the factored form. Okay, and let's try the next one. So we make our x, and multiplication on the top, addition on the bottom. First number times the last number is -10, and middle is 3. What multiplies to -10 and adds to 3? 5 and -2. 5 times -2 is -10. 5 plus -2 is 3. Split the middle. So we have 5x minus 2x, which would bring me back to the 3. Bring down the 5x squared and bring down the -2. And then we group. The GCF here is 5x. If we factor that out, we get x plus 1. And over here, it's -2. And if I factor that out, I get x plus 1. And then we smile because these match. X plus 1 times 5x minus 2. And there's your factors. One more to look at here. So multiplication, addition, first times last is 20. Middle is -3. What multiplies to 20 and adds to -3? So 20 is 1 times 20. Nope. 2 times 10 won't work. And then 3 does not go in. 4 times 5 does not work. So if we're looking at this and saying, well, I can't come up with anything that multiplies to 20 and adds to -3. So this is not factorable. Okay. So we call that prime. If you can't factor something, it's prime. And you can just write prime as your answer. Okay, so nothing multiplies to 20 and adds to -3, so we stop at that point and we write prime. When a polynomial cannot be written as a product of two polynomials with integers, it is prime. That does not mean later that we won't be able to do something with it, but currently we just say prime. We cannot factor this. We can do other things with this quadratic, but not factor. Okay, and we'll learn further about what we're going to do with all this factoring in a future lesson. So you have a worksheet. Make sure you make them X. It makes it easiest. Always look for a GCF first. It gives your terms smaller. Once you finish, split the middle and then distribute, and then always check your answers.